I say good morning, even if it is evening on my side. Welcome to this presentation on XR venues, live theatrical stage performance. This is one of the 3 projects that we are kicking off this week. Together with the 5 standards that are published for community comments. So this is all the result of MPI work. MPI stands for Moving Picture Audio and Data Coding by Artificial Intelligence. We are an international unaffiliated not-for-profit standard development organization. We are based in Geneva. We develop AI-based data coding standards, and we wanted to attach a clear intellectual property right licensing framework so that once the standard is developed, we don't have surprises that prevent or delay the adoption of the standard. So this is the organization. If you go here, development committees, this is the part where we have groups that are actually in charge of developing standards. Then we have the requirement standards committee that includes a large number of explorations. One of them is the last one here, XRV. We do hope that by responding to this call for technologies, XRV will move to development committees, and that will happen in a couple of months. So we talk about standard, but how are standards developing in MPI? Anybody can come and propose something. We develop use cases where this proposal can be used. We develop functional requirements and commercial requirements. When both are ready, we issue call for technologies. We receive proposals for solutions, technologies, and so on. When the standard is close to done, we publish the standard for asking for community comments, and after that, we publish the standard. We would like to think that we are working for a standard that gives a better AI. And we do that by making explicit the computing workflow of AI applications. So what we do, we break up monolithic application into a set of interacting components. These components exchange data with known semantics to the extent possible. Then developers can take up the standard, and they can develop components that are standard because they expose the right interfaces, but have potentially an improved performance, depending on how well the standard has been implemented. But then we human users can select applications whose internal operation we understand. It's not a big black box that we don't understand what is inside. So this is our motto. Our standardization is component-based, and it is implemented by subdividing an application in smaller components. We aggregate the components in workflows, and we execute the workflow in a standard environment that's called AI framework, AIF. And this is the name of the standard. So this is the model, the reference model of the AI framework. And please pay a little bit of attention, because what Ed will say later is largely based on what this reference diagram says. So we have an environment where we can execute the workflows. We have inside AI modules that are variously connected. We have a space for storage, secure, non-secure. Then we have the controller. The controller is the brain of the AIF, is the one that controls the progress of the execution. It exposes API for the AI modules. It can access communication, global storage access, and what is important, the MPI store, because we wanted to create a watertight system whereby you can download from a secure environment of the Empire Store. You can download not application as it is today, but modules that we can combine and create applications. We also have access to the security abstraction layer, exposing communication, trusted service for secure communication service, encryption service, and attestation service. MPI creates an ecosystem. It's not the only one creating an ecosystem. Any standard does create an ecosystem where we have, okay, the body that develops the standard, we have developers, we have integrators, consumers. Because we are dealing with artificial intelligence, and artificial intelligence at the micro level, not at the level of a big application, then we have identified the need of an entity that we call the Empire Store. I've talked about it, but this is not the say the server. Here we are talking about the organization which we have established in Scotland as a non-for-profit organization. Empire Store is independent of MPAI and has a charter that is published on the web. So the task of the Empire Store is to guarantee that modules and workflows are interoperable, trusted, and available. And this is contained in the governance of the Empire ecosystem. So this is how it works. So we have Empire developing standards, we have implementers taking up standards, then we appoint performance assessors. So we do that. These people are in charge of measuring, assessing how good an implementation is. They are appointed by MPAI, but they are independent of MPAI. So assume that an implementer has created an implementation, submitted to the performance assessor. Let's assume that the assessment is positive. Now we have the Empire Store coming in. The task is to verify the security of implementation, test the conformance, and check the performance. Test and check are two different words because for performance, the Empire Store relies on the assessment of the performance assessor. So finally, the implementer can submit an implementation, and the Empire Store does all the tests that are required and can post the application on the Empire Store so that users can download the implementation and use the implementation and provide feedback on their experience. Empire has published more standards. We have a 4 technical specification on audio, the group that was meeting the hour before, compression understanding of financial data, multimodal conversation, machine to machine, but including emotion, and neural network watermarking. We also have 2 technical reports on functionalities and functionality reports of the Empire Metaverse model. We have 5 standards, as I said at the beginning, that are published for community comment, and we expect they will become standard at the end of this month. Here they are. We have version 2 of the AI framework. We have version 2 of multimodal conversation, and we have avatar representation animation, connected autonomous vehicles architecture, and Empire Metaverse model architecture. But that's not the end. And the fact that you are here is a proof of it. We have comfort technologies out for artificial intelligence for health, object and scene description, and extended reality venues like theatrical stage performance. More is being explored. We have 2 projects on different approaches to AI-based and video coding, and we have also a project on an exploration on online gaming. I'm happy to announce that this has happened earlier this year, that we have 4 standards that have been adopted by IEEE without notification. They are the AI framework, the audio one, the multimodal conversation, and the financial one. We are waiting for a final approval of the neural network watermark. So you can understand that after this, Empire people want to be proud that they have reached all this in less than 3 years. But you are in charge of developing a new story inside MPAI. So that is the reason why XR Venues, this presentation, XR Venue Light Theatrical Stage Performance, is up to Ed to present. And so please.
Welcome, everyone. And my name is Ed Lance. I've been designing immersive theaters for a few decades. I'm very excited to be supporting Leonardo with this great work that he's doing through MPI in the creation of standards for immersive theaters that combine with the metaverse to create an in-person and metaverse XR experience involving live performance. So jumping right in here, just a little bit about terminology we're using. XR, of course, is extended reality. It's a catch-all phrase now for virtual reality, augmented reality, mixed reality, spatial augmented reality, whatever. By venues, we're referring to both real and virtual environments. So that's really the key here, is that we're helping to bridge between real and virtual worlds and create events that go across those worlds. There's a number of different elements that are used in making that happen, including possibly domes and or projection mapping, AR glasses. And the idea is we're bringing actual participants in. We prefer to call them participants rather than audience, because these can be highly interactive environments. So just to reiterate, we're looking at how to bridge between and automate both a real world environment and or a virtual world environment, or multiple of the two. So for instance, and then of course, bridging that with a current concurrent event. So what we're seeing here in the business, if you will, is increasing use of video scrims, backdrops, projection mapping in theatrical stage performances, Broadway theaters, musicals, operas, and whatnot. You know, the more increasing use of digital sets to augment or even in lieu of physical sets. The domes, as I've mentioned, can be LED volumes or projected environments that surround audience. Again, this concept of combining a real performance with real world with a virtual environment. So to move on here, this is what we started with. I'm not going to go through this in any detail, so don't worry about that. But basically, what we try to do is map out all of the bits that might go into a live performance, which might include a DJ, VJ, console operators for show control, lighting, whatnot. Of course, so you have a live audience and a live stage performance. You might have a live metaverse, and of course, customers or participants, if you will. And then we're distributing the experience or putting it out there as a VR, AR experience, a dome or a live stage environment, virtual environment, and also streaming as another possible way to distribute this content. So this might be, this is a picture of where this is headed. You see it happening now, where you have multiple domes that can be networked together. The planetariums have done quite a bit of that, dome casting, if you will. You have virtual environments that are shared. And you can also have performers coming into these environments either on a stage as a mocap character, volumetric or whatever. And then it's all tied together with a social media network and participants can join even on a mobile device, if you will. So the reason for bringing AI into this sort of architecture is multifold. One is just the mounting of shows and adapting them to different venues that might have subtle variations or even large variations in the configuration of lighting, projection. You know, there can be a lot of differences from venue to venue. And what we're looking for is a way to rapidly mount shows across multiple venues and preserve the core of the experience. And AI is a great candidate for that. Also, orchestration of lots of systems. You know, a Broadway show or a Cirque show or whatever. You know, you have a lot going on there. There's a lot of moving parts, and to the extent that we can help amplify a console operator to help them to reduce the complexity of their work, or in some cases where you have large shows that you want to tour to a smaller venue, but you can't afford the extensive staff, perhaps automate some of that real-time experience that's happening. We also want to, of course, span the virtual and real environments and allow participant interactivity. AI can help with that. And also, you know, in essence, what we're doing is we're shortening the connection between the artist conceptualizing the show and the actual delivery of that experience to the participants. So it's sort of like bridging the gap between the mind of the artist and the mind of the audience, and making that a more direct expression from the artist. And you know, one embodiment of that might be, like, you've seen DJs, you've seen VJs. We're looking at touch jockeys now, where you actually have haptic experience that you can deliver. Putting all of that into the hands of one real-time performer is possible with AI, where through gestures or through other performance modalities, a single person can orchestrate a very complex experience. And the other thing that's very interesting about AI is this ability to, whether it's generative AI or whatnot, to be able to bring assets in from the participants themselves who have maybe opted to share even like a Facebook page or Instagram page, and where you can pull assets off of their personal assets and incorporate them into the experience in a meaningful way. So each show could be different. So we put out this call for technologies. We're looking for support in defining the AI module functionality. What do these modules have to do? And we'll get into that in a minute. But also the protocols for how the modules talk to each other and the data formats as well. So the idea is to use the technologies to help refine and develop this specification, which then could involve licensing your technologies as part of the framework license. So this is the general architecture that we have to date. And of course, we're open to comments and additions to this, embellishments, or helping to define it better. But what we came up with is really quite interesting. What you see here is a bidirectional coupling between, in this instance, a real environment and a virtual environment. We could be coupling multiple virtual environments or multiple real environments. You know, but this is a general model for coupling two experiential domains, if you will, where you have participants. And what we're doing is we're extracting data out of the real environment. This could be motion capture, volumetric capture, it could be a tracking, it could be video, whatever, from the real environment. We're capturing that data, we're extracting certain features from that data, and then interpreting those features in accordance to the script, which then results in the generation of actions. Those actions can feed back into the real environment but also feed into the virtual environment. So likewise, from the virtual environment, we're doing the same thing. We're collecting data, extracting features, interpreting them, and generating actions that go back into the virtual and or the real environment. So this is just a flow of action saying, okay, here's all the elements, if you will, for such a system that such a system might include, right? So a physical stage doesn't have to be a stage, but that's typical. Lighting and projections, there could be multiple display components, special effects, which could be wind, mist, tactile haptics, whatever, pyro even. The audience could be standing or seated in either real or virtual venue. And you can also have an audience out there, the participants who are we're streaming to, perhaps on their mobile device. Interactive interfaces allow audience participation. There's a number of ways of doing this that we'd like to be inclusive to. We don't want to exclude, but that could be voting, perhaps on a mobile app. It could be real or virtual action generation, but the idea is that the audience can participate in a meaningful way. It could be gestures and such. But also you have performers on a stage, or they could be moving through the audience. They could be positioned around an immersive environment. And you have a multi-sensory delivery system, which could be aroma and all like that. We also can capture biometric data from the audience and or performers. An easy one are capacitive heart rate sensors in the chairs. You can also sense heart rate with the near IR camera now. And then we also want to allow for show operators to manually augment the show. We're not trying to take away real-time control from operators. In fact, an operator can help guide the AI in the performance of the show, or can recover from something that happened on the stage that wasn't scripted or whatever like that. So, you know, of course, the show operators can train the AI to perform the show as well. And we have a virtual environment that mirrors selected elements of the real environment. So what's cool about this is this ability to capture performers on a stage through mocap or through a 2D image that we capture of them and key out, if you will, and place on a card in a 3D environment, or perhaps raw volumetric 3D images, spatial mesh or point cloud of the performers on the stage that can be lifted and put into the metaverse. Likewise, the real environment can be projected onto your immersive venue. So, so you might have the situation where you have a sky on the dome, you have a sun moving across the sky, and projection map shadows moving across a stage, these sorts of things. So the entire stage can be projection mapped or wrapped with LEDs to bring that virtual environment into a physical room. And then there's other things, of course, AR glasses and immersive environment allows users to actually interact with objects in front of them, or objects that come into the room and interact with specific people or whatever. And of course, there's lighting and whatnot, which are critical to both the real and virtual world. We're also looking at real set pieces on the stage. And, you know, the Holy Grail here for the live environment, the real world environment, the Holy Grail is that you can't tell where the stage ends and an infinite environment begins. So the dome or the backdrop or whatever the case may be, a panoramic display, extends. It's like a set extension out to infinity. So this is the Holy Grail. You see attempts to do this on stages now, and you're going to see it more and more in the future as these big dome projects like the MSG Sphere are launching later this month. 17,500 seat dome with spatialized sound and all kinds of interesting effects. So of course you have real performers on the stage who move about, and we're mirroring them in the virtual environment. Virtual performers can also be brought into the real world theater. So it could be a performer on being projected on the dome who's actually an avatar in the virtual environment. It could be a volumetrically captured character in the virtual environment that is now ported over onto the dome or onto a holographic screen like that. And behind all of this is the script. The script is essentially a cue list, but with a lot of detail, guiding and synchronizing the actions of all of the AI modules in this system. So the show evolves from cue to cue, scene to scene, and the AIMs can embellish the show in real time, depending on what the performers do, because it is a live performance. So it's not like you push a button and it's a canned show that runs. There can be spontaneity on the stage, and the AI can follow that and work with that. So what we have here is there's a block diagram showing typical inputs and then outputs. We're taking data in from both the real and virtual environment. And we're not too specific here in the sense that some of this data can be coming from both of these worlds. Things like biometric data or audio or video or whatever. So we're taking this in, and then these various AI modules shown in green here are the processing elements, the automated processing elements that are required. As Leonardo said, this is not a black box. What we have are lots of little black boxes doing AI, specific AI functions. And this is what the call for technologies is relating to here. So, and of course, again, you know, the script is sort of your overarching, script just describing the show flow. So within this, these are the names of the AIMs, their function, their input, and their output. We've created some new terms here for these signals to sort of bundle these multiple things together, which are described in the document, in our documents. So what you have here, this is what we're looking for in the call for technologies. We're looking for support, defining these functions, and defining the input and output formats, particularly any proprietary formats you might have that would put us way ahead of the game, or under the license agreement, or perhaps just standard formats that you know of that could really round this out in a bigger way. So these are the technologies regarding the interface definitions here of all of the interfaces and signal flow through the system. So what I'd like to do is briefly go through the AIMs here and just give you a feeling for what they do. This is a summary of what's in the document. There's more detail in the document. So here, performance description. What we're doing here is we're collecting all the data we can of the real-time performance, either from a physical stage or from a metaverse performance. And we're consolidating all this information into a succinct signal here we call scene descriptors. This data here requires a definition of a format that is describing what's happening on the stage. Now, it could be a conglomeration of different formats, but for instance, the raw mocap data coming in here, it might be performer number 1, performer number 2, performer number 3. We need to describe what they're doing and who they are in the script. So the scene descriptors are congruent with the script, and now we know what's happening on the stage, so to speak. However, the next block here, and these scene descriptors are used elsewhere in the system as well, but in this particular flow, the performance status is derived from the scene descriptors, which tells us essentially where we are in the script. Okay, the performer, actor number 1, raise their hand, trigger the lightning, or like that. So this scene description advances the cues, and the cue point tells us where we are in that. And of course, this can include audio, video, and the cue point is essentially where we are in the script. So, and that could be defined by what someone says, what someone does, a dance, what a prop is doing on the stage, or whatever. So this is this block here is also collecting data. It's collecting data from the participants. The AV here might be, for instance, a camera looking at the audience with a microphone. So we can tell when the audience cheers. We can tell when the audience is waving or whatever. And we are consolidating all of this raw data into a succinct description of what the audience is doing. But now this description has to be interpreted. So we have a separate AIM that now extracts the features that, or that interprets the features that have been extracted. It interprets them. And these might include things like sentiment, or emergent behaviors, like if people are doing a wave like they do in a stadium, like that. So that's how we are taking in data from the participants. Likewise, we have data coming in from control surfaces. These are consoles, typically with an operator, or it could be a actual show control computer, perhaps, but it's feeding into the system and it's saying, okay, time to hit this cue, or let's bring up the volume a little more here, or whatever. So this is where we have live intervention into what the AIs are doing from operators. And of course, how the controls are interpreted depends on where we are in the cue list, in the script. If it's scene 1 and I push this button, we want the sun to set. If it's scene 2 and I push this button, we want the moon to rise, or whatever like that. And so now all of this data, the scene descriptors, the interpreted operator controls, the participant status, all goes into now an action generation block, which is looking at the script. It's looking at where we are in the cue point and what people are doing both on the stage and in the audience. And it's saying, okay, here's what we need to do next. We need to trigger the video server that makes the sunset. We need to trigger the moon to rise. We need to dim the lights. It's an end of scene 1, lights out, or whatever. And these actions, and this is a key piece here that needs some work. We want succinct action descriptors. This could even be like text prompts that are generic. They're not specific to the theater, but they're describing what we want to see happen now as a result of everything that we're seeing on the stage and in the participants. What do we want to, what change do we want to drive? What action do we want to drive in both the real and virtual environment? So from that, from these action descriptors, we now want to talk to the environment. And in this case, we have a real environment. So we're driving the lighting, the effects, the AV. In some cases, we're feeding raw data from the scene descriptors. Might be something like routing the volumetric point cloud. And when it comes into this block, the action might say, well, we need to modify the texture on some of those characters now based on where we are in the script or whatever. So all of that then goes into both the real and correspondingly virtual environment. And each of these sort of output signals have protocols that depend on the real environment and how it's configured. Like, for instance, how many lighting fixtures do you have? Where are they placed spatially? How can they be used? What are their commands in the DMX protocol? So in order to send the right commands, we need to know what the theater configuration is. And that's where the venue, in this case, the real environment venue specification, actually needs to be input into this experience generation block. This is not necessarily a real-time signal, but we need to know what it is we're trying to control. We have a generic description of what we want to see on the stage or in the metaverse. And this AIM takes that generic description and makes it real, cognizant of what we have to work with in that environment. So that is the case in the real environment. It's also the case in the virtual environment. And it's a little more complex in the virtual environment because here we can have a variety of controls on 3D geometry, shading, lighting, materials, physics. Properties might be varying according to the script, right? Our best guess right now on how to do this piece, because we've lumped a lot together in this one term, is something like OpenUSD. That might be a good candidate for how to control a virtual environment, control actions in the virtual environment in real time. You also have AV signals. These could be signals telling the video to fade, or mixing channels, or audio telling you where to route the audio. Because think about it, there might be audio here that need to be fed to a character. Or there might be audio here that needs to be fed to an object moving around in the metaverse. So we need the spatial position of that audio source, as well as the signal itself. So that's all bundled into this definition and broken out a little more detail in our documents. The virtual experience venue specification, again, tells this AIM, okay, here's what you got to work with. You can change the textures on these characters, but you can't change the textures on the mountains. This is so there could be limitations. There could be additional capabilities that some virtual environments might have above others. The idea is to have the AI sort much of that out rather than making it a manual process. So that's pretty much a walk through the work we've done so far. One thing that we like to put out there is that this involves sensitive participant data. We're not explicitly addressing the processes required to oversee the collection and proper management of that data, but we are assuming that whatever processing is carried out does conform with ethical legal standards and that might actually be constraints that have to be put in and interpreted by the AI module so they know what we can and can't do. There might be certain participants, for instance, that have said, don't put me on a camera. I don't want you taking my data or doing anything with it. And so we need to build that into the system essentially. So So that is basically my presentation. And Leonardo, if you'd like to take it over from here, and I'll go off camera. But thank you guys again for showing up, and all those out there watching this video after the fact. This is the call for technologies. Bring it. There's a small team, and certainly can use any support that you'd like to provide in refining this spec to guide a standardization of these venues, so that, as you might imagine, like with theater, like with cinema, that when you have standardization, now you can plug and play shows and distribute them more widely. So this is very important work as we move into these new technologies.
Right. Thank you, Ed. Of course, the story does not end here, because after this couple of slides, we will have an open discussion, but that will not be recorded. So let me say 2 words about the framework license. Framework license is not a license. It is a collection of guidelines that people contributing technology should accept in order to participate in the development of the standard. As I said, we want to be very open. We wanted to create opportunities to people who own great technology to find benefits out of their invention or patents or whatever. But we want to make sure eventually that if we have a standard, the standard can be implemented. So it is, therefore, the coverage is that, okay, there will be something called the XR Venue 6 Empire XRV, Live Theatrical Stage Performance. That will be the Empire standard. And so this framework license relates to that. We ask all contributors to the standard to confirm in writing that they will make available a license to their essential IPR based on the condition of use of the license that I'm going to introduce. So here we have a collection of rather general statements. The license should be in compliance with the general accepted principle, competition law, the Empire statutes. The license will cover all claims, not just a part, to essential IPR and copyright of a licensor that is needed for implementing a standard. The development rights and the implementation rights, the license will cover both, and the license will grant access to essential IPR of the standard in a non-discriminatory fashion. Number 4 is added because AI is a strange beast, and it may be so that some parts must be subjected to legal bias, ethical, and more limitations. Continuing, now we're talking about the royalties. Royalties will apply to a baseline profile, but there could be more profiles, and the royalties shall apply to all. Shall apply to any implementation and is based on the standard, but there's some exemption that I'll talk in a minute, and should apply on a worldwide basis. An implementation of the standard may use other IPR in order to make a complete system. That's, it's just that because it is in combination with other IPR, you cannot tell me that the license is no longer valid. Exemptions. So if you want a license for development and implementation rights, but you only want to use it for a demo or for technical trials, that will be free of charge. A license may be granted free of charge for particular uses, if this is decided by the licensor, and a free of charge license for limited time, limited amount of forfeited royalty will be granted on request. Finally, we wanted to make sure that there is a working organization to administer the patent pool of holders of patent essential to the standards. Then the license will be issued before commercial implementation of the standard becomes available. So this is the best answer to the question that people ask. when can I have the license? Well, we say that if someone else is on the market, you also should be on the market. This is what we are saying. Number 10, the total cost of the licenses will be in line with the total cost of the license for similar technologies. So it cannot be 10 times. And whether it should be 1.5 is still acceptable or not, that's a matter for lawyers and for patent holders to decide. The total cost of the license will take into account the value on the market of the standard essential IPR. Then I have 2 words about the documents that constitute the call for technologies. So first of all, anybody is entitled to respond to the call. The responses should reach the Secretariat by the 20th of November. And you see here 4 documents in HTML, PDF, or docx. We have the call for technologies proper. The use cases and function requirement is essentially what Ed has introduced. The framework license, I mean, it's a little bit more than what I've shown, but it's essentially that. And then we thought that it would be useful for you to have a template so that you know where you should put the text and you should not scratch your head trying to understand. So with that, I think that thank you very much for your participation, and we do look forward to working with you on this exciting MPI project. And there's an easy way to do it by joining MPI, and then you can share the fun and build the future. Thank you.